Hello, my name is Hannah. I did my genetic project on Nettie Stevens. She was an American geneticist in the late 19th century and early 20th century. Her most notable finding was the discovery of sex chromosomes. So Stevens was born in Cavendish, Vermont on July 7th, 1861. Unfortunately, her birth mother did die when she was 2 years old, and her 3 siblings were raised by her father and then later stepmother. They were a middle-class family. The father was a carpenter and he supported her 2 brothers and younger sister. And the photo is Stevens at age 19. Stevens was very close to her sister Emma when growing up. The entire family moved to Westfield, Massachusetts after her father remarried to Ellen. Stephen's stepmother Ellen was a great help to the family as it was difficult for their widower father to care for 4 children on his own. Nettie and Emma attended Westfield Normal School in Massachusetts where they lived. The school trained teachers, and Stevens took only 2 years to graduate instead of the typical 4 years. After graduation, Nettie worked as a teacher, librarian, and assistant principal for 13 years, but she didn't really find joy in that. She truly wanted to do research of her own. So during the time period, Stanford University, then known as Leland Stanford University, did not accept women commonly, but Stevens was still accepted and she enrolled in 1895. She earned a Master of Arts after 4 years and immediately went on to graduate school at Bryn Mawr. She began her research career while still in school at Bryn, publishing her first paper in 1901, and then 2 years later in 1903, she earned her PhD from Bryn Mawr. After earning a doctoral degree, Stevens was suddenly employed by Bryn Mawr. She taught as well as conducted research there. It was no secret that Stevens preferred research over teaching, but she persevered nonetheless. She taught and researched until her death at age 50. Stevens researched various topics such as morphology and taxonomy of ciliate protists, cytology and regenerative processes, and most notably the sex determination. Her first paper was on cytology and the regenerative processes, while she published a paper alongside another great researcher on morphology and taxonomy of ciliate protists. However, her priority always remained on sex determination and the X and Y chromosomes. Thomas Hunt Morgan wrote a paper with Stevens in 1904 on the cytology and regenerative processes. Edmund Wilson discovered sex chromosomes independent of Stevens in the same year. And lastly, the president of Bryn Mawr was also a good colleague of Stevens. He gave her a recommendation for a research position at the same institution, and so did the 2 previous colleagues of hers. As mentioned before, Stevens was most well known for her discovery of the X and Y chromosome and that they determine sex. While studying aphids, she observed females only have X chromosomes, while males have X and Y. She hypothesized that sex is inherited as a chromosomal factor, and males determine sex since they can carry the Y chromosome, typically. During the study, Stevens used an abundance of equipment. She used Gilson's alcohol with sublimate, iron hematoxylin, Fleming's fluid, and an abundance of others. Other equipment included needles for opening the body cavity of the insects, which allowed her to obtain genetic material, as well as a microscope to look at the chromosomes themselves. And lastly, 13 aphid species were utilized during the research. The methods of Stevens' experiment were fairly consistent. A needle was used to open the insect body, and Gilson's alcohol with sublimate for fixation. Next, the iron hematoxylin method was then used to stain the genetic material. The 2 solutions to carry out this process were iron mordant and hematoxylin solution. She tested out a few others as listed in the previous slide, but they just didn't work as well. The process was repeated several times in order to get the correct staining. After staining was complete, chromosomes were observed, counted, and drawn, as shown below. These are the actual drawings in her paper. The main discovery was the existence of X and Y chromosomes. Males have an X and Y, while females have two X chromosomes. It was noted that each of the aphid species had a unique number, form, and size of chromosomes. Additionally, it was found that a double series of homologous paternal and maternal chromosomes is present in parthenogenic generations. The homologous chromosomes are paired side to side in the first spermatocyte and presumably in the oocyte of the sexual generation. No heterochromosomes were present, however, the spermatids are alike pertaining to number, form, and size of chromosomes. Lastly, parthenogenic individuals may produce all parthenogenic embryos, and winter eggs, all sexual female embryos, all male embryos, parthenogenic and sexual female embryos, parthenogenic and sexual male embryos, parthenogenic male and sexual female embryos, male and sexual female embryos. These are drawings of the aphid chromosomes which Stevens observed during her research. These are the first two, and these are the second two. So because Stevens was a woman, there was more difficulties than if she was a man. I mean, even today, it's difficult for women to get the funding and the research positions they want just because of their gender. But especially because of the time period, just attending college was rare for women, let alone making discoveries. Some argue whether Stevens did not get the recognition that she deserved at the time as Wilson due to being female, but some also say that she had already passed away, so that could have been the reason as well. Stevens left a deep impact on the world of genetics. First of all, the chromosomal theory became widely accepted due to the fact she found a correlation between a specific trait and a pair of chromosomes. Additionally, it was established that sex is hereditary and not influenced by the environment. And although this doesn't really pertain to just genetics, but she is a leader influencing women who want to go into STEM, not just genetics, but all fields of STEM, because of the time period and the fact that she was a woman. Nettie Stevens worked at Bryn Mawr College until her death at age 50. She passed away due to breast cancer. Like many female scientists, her work was not recognized before she passed away. However, she's appreciated almost every day in the modern world when students learn about genetics, specifically the X and Y chromosome. And those are my works cited.